Okay, now we're going to start a lesson on resistors. And in this lesson, we're going to learn specifically how to identify a resistor based on its color-coded banding. And there's a couple different ways of doing that. And then at the end, we're going to learn about the symbol that we use in schematics. So in this lesson, we have some objectives. The first is to understand that color coding system that I talked about and distinguish the value of the resistors based on that color coding system. Determine the nominal value of a 4-band resistor and determine the nominal value of a 5-band resistor. There are some different systems that we're going to use to identify the value of the resistor, and one is 4 and one is 5-band. And then be able to determine the allowable tolerance range between the high and low of a given resistor, and we'll get into that here in the lesson. Okay, some sort of resistance is required in any electrical circuit. If you think about your car battery, screwdriver drops across the terminals, that is what we consider a short, and of course you get sparking, arcing, and could even severely damage your battery. Every circuit needs some sort of resistance, and that's why we're starting off with studying resistors here. And without any resistance, the circuit is considered what we call shorted. When we get into labs, we'll discuss shorts in more detail. So here, there is a color code for the banding, and the color determines a specific value. So the first color that we're going to look at here is black, and that's going to have a value of 0. Brown will have a value of 1. Red will have a value of 2. Orange will have a value of 3. Yellow will have a value of 4. Green will be 5. Blue is 6. Violet, or some say purple, will be 7. Gray will be 8, and white will be 9. And if you look at that, that is the colors of the rainbow, with black and brown on the front and white on the end. So some people know the Roy G. Biv as the ROYGBV for the colors of the rainbow. And if you put black and brown at the front and white at the end, you get this whole spectrum here. But I have a mnemonic to help us remember that. So if you just remember, better build roof over your garage before van gets wet. Those are the first letters of each significant color in the color chart here. So better, B for black, build, B for brown, roof, R for red, over, O for orange, your, Y for garage, garage, G for green, before, B for blue, van, V for violet, G, gets, is for gray, and wet, W, is for white. Okay, so better build roof over your garage before van gets wet. Resistor band systems. Most resistors use a 4-band color code system, and that was actually true up till just recently. The cost of resistors has come down, and it could be 4, it could be 5, and we'll look at that a little bit more as we go through the lesson here. But this one is a very common one, the 4-band resistor. And then a precision resistor uses 5 bands, and it's going to have a tighter tolerance. We're going to learn what tolerance is in just a moment, but a precision resistor will use 5 bands in that case. Okay, so we're going to look at a 4-band resistor here first. Here is a picture of a resistor, and it has these color bandings on it. And the important thing to know about how to hold this, to read this left to right as far as the banding goes, is where are the bands closest together. So in this case, this orange and white band are very close together, and so we know to hold that to the left, and we're going to be reading from left to right here. Another thing that kind of gives it away is there's a silver over here to the right, and we're gonna find out why that would give it away as well here in just a moment. So the orange band is going to be our first digit. The white band will be our second digit. The yellow, this is in a 4-band system, is our third band, and it's going to be a multiplier band. And then the fourth band is going to be our tolerance band, and we're going to learn about what tolerance is in just a minute. So let's look at our resistor tolerance. Tolerance is an acceptable range in which a particular resistor value may fall within. And tolerance is found on that fourth band on a 4-band resistor. So here we could have on that fourth band a gold band, and that would mean that this is a 5% tolerance resistor. And then we would have a silver band, and that would mean a 10% tolerance. Now, if you have a very old resistor, it would actually, some of them would only show 3 bands, and that means that there is the absence of a band there in that fourth band position, and that means a 20% tolerance. That is a very inexpensive resistor, and they really don't make those anymore. But just in case you would find that, and try to discern the value of a resistor. If it has no fourth band, if it just has 3 bands, that would be 2 digits in a multiplier with a 20% tolerance. Okay, so we're going to work through some problems that will clear this up a little bit. The resistor value of a 4-band resistor, we're going to go with that same resistor that we had in the previous slide. And here I just have a little chart here to help us remember that. Black, brown, red, orange, yellow, green, blue, purple in this case, what I was calling violet in the other slide, gray and white, and that's 0 through 9. And then if you see down here, we have a gold as 5% and a silver as 10%. We're going to get into what brown and red are on the 5-band resistor system. So right now we're on the 4-band resistor system, and we're going to look at discerning the value of this resistor. So the first digit is orange, so that means a 3. The second digit is white, that means a 9. I'm getting those from over here. So here's my orange, there's my value of 3, and then my white here is a value of 9. Okay, so those are the 2 significant digits that I have. And then I have a multiplier, and my multiplier is a yellow band, and yellow has a value of 4. Okay, so that's why I have 4 there, and we're going to find out how to utilize that here in just a moment. And then I have a tolerance band of silver. Okay, so my first 2 digits I just write down 39. I have a 3 and a 9, and then my yellow in my third band means that I'm going to have 4 zeros behind my 39, or I could say I'm going to take 39 times 10 to the 4th. That would be saying the same thing. So in that case, I would have a nominal value of 39,000 ohms, or it's saying it in engineering notation would be 39k ohms. Okay. Now I'm very specific here. I say that this is the nominal value, and the nominal value means that that's the basically target value for this resistor. It may not, if you measure this with your volt ohm meter, you may not actually get 39 ohms, and we're going to find out on the tolerance band what is the acceptable range here. So let's look at the tolerance band, and we need to apply that to this same resistor. So we have a tolerance band of 10% because it's silver. And so if our tolerance is 10%, that means the decimal equivalent of that is 0.1. Okay, so if I take my 0.1 and I multiply it times my nominal value of 39,000, I get 3,900. Okay, so that is the value, either plus or minus, that I can be of my nominal value to be able to have a good resistor here. So if I subtract my 3,900 from my 39,000, I get 35,100. And if I add it to my 39,000, I get my 42,900. So the acceptable range for this particular resistor, because it's a 10% tolerance resistor, is actually going to be from 35,100 ohms to 42,900 ohms. Okay. Now there is an exception for the third band. Some resistors have a very, very small resistance. This is going to apply to resistors that have a resistance that is of 0.1 to 9.9 ohms. Okay, these are kind of rare, but you could run across these. And so the third band is used to move the decimal place to the left instead of to the right. Okay, and we're going to show how that would apply in in the field. Here, if you have on the third band, not the fourth band, but the third band, a gold band, that means you're going to multiply by 0.1. And if you have a silver band in that position, you're going to multiply by 0.01. So let's do an example here. Here is a resistor that has in its third band a silver band. That means that we're going to have a very low resistance resistor, and we need to discern what its value is. So our first digit is orange, our second digit is yellow, so I have a 3 and a 4. Okay, my multiplier is going to be 0.01. So we're going to be moving the decimal to the left in this case. And then my tolerance again is at 10%. So my first two digits are 34, and my silver band on the third position means that I'm talking about hundredths. So that would be 34 times 10 to the negative 2, or just moving the decimal place over 2 positions to the left. So that would give me a resistance value of 0.34 ohms, or you could even write that in engineering notation as 340 milliohms. This again is a very rare resistor. That is a very low ohms resistor, and normally they're of higher resistance, but it is important that you could run across this in the field. Okay, let's look at a 5-band resistor. Okay, so in this case we have 5 bands, and again we have the bands are closer together on this side than they are on that side. Okay, so we know that this is going to be our left side, and we're going to be reading from left to right in this case. So our first digit, second digit, and third digit now will be significant numbers, and then our fourth band will be the multiplier, and then we're going to have a tolerance band. And if you notice, that tolerance band is not gold or silver. It's going to change. This is, remember, a 5-band resistor is a precision resistor. Okay, so it's going to even have tighter tolerances than a 4-band resistor. Okay, let's apply this and find out its value. The first digit is orange, so that would be a value of 3. Second digit is orange as well, another value of 3. The third digit is white, so that would be 9. And then our multiplier in this case is a 0. And we're not going to multiply it by 0. That just means there are 0 zeros. And then we have a tolerance band, and we're going to talk about tolerance in the next slide. So the first 3 digits are 339. Okay, and then the fourth band means 0 zeros, like I said, or you could think of that as 339 times 10 to the 0. You take any number to the 0 power, that's going to equal 1. So this is 339 times 1, which is just equal to 339. Again, it just means 0 zeros. Some people might incorrectly think that this is 3390, thinking 3,390, and that would be incorrect. It's 0 zeros. It's not tacking a 0 on the end there. Okay, very important distinction to make. So the resistor's nominal value, again, the value that it should read, would be 339, but we still do have a tolerance. We're going to look at that on the next slide here. So we're going to, in this case, the tolerance is the 5th band. We're going to apply that. This tolerance is the acceptable range for this particular resistor to fall in, and it is the 5th band on the 5-band resistor. And in this case, we have some more colors added in because it is a precision resistor. So brown is going to mean 1% tolerance, much, much tighter tolerance than we had in a 4-band system. Red would equal 2%. And then we have our what we had in the 4-band system as gold would be 5%, silver would be 10%. So in this case I have brown here, and that is going to mean a tolerance of 1%, and let's apply that to this resistor. So 1% would be the same as multiplying by 0.01. So if we take our 339 ohms and we multiply by 0.01, we're going to get 3.39. And if we subtract that from 339, we're going to get 336.61. And if we add it, we're going to get 342.38. So our acceptable resistance range is going to be 336.61 to 342.38. Okay, that's my acceptable range. You can see it's a much tighter range on this precision resistor, and that's why it is called a precision resistor. Okay, so let's review here. Understanding the color code system used to distinguish these resistors. So let's look at these colors here. Here's my chart, and my mnemonic is going to be better build roof over your garage before van gets wet. Okay, so that would be black, brown, red, orange, yellow, green, blue, violet, gray, and white. And if you think of them in that order, if you start at 0, that would just be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and then we do have, on a 4-band system, we would have our tolerance here of 5%, and tolerance of 10% for silver. And then when we talk about the 5-band system, we're going to have 1% for our brown and 2% for our red. Okay. Let's determine the value of a 4-band resistor. Here's a different resistor for us to discern the value. First digit is red, so that's a 2. And the second digit is black, so that's a 0. So that would give me a 20. And then our multiplier would be 4, so we would have 4 zeros behind the 20. Okay, you don't want to include this 0 in the 4 zeros. You're adding 4 zeros on top of that. Okay, and then our tolerance is 5%. So 2 digits, 20, and then the third band of 4 means we're going to take the 20 times the 10 to the 4th. Okay, we don't want to have 4 zeros behind the 2. We want to have 4 zeros behind the 20, and that's going to give us 200,000 ohms, or we could simplify that in engineering notation by saying 200 k ohms. Okay. Let's determine the value of a 5-band resistor. This is actually a typo. That should say 5-band resistor there. The first digit is brown, so that is 1. The second digit is black, which is 0. Third digit is black, which is going to be another 0. So that's going to break down to a 100. And then our multiplier is going to be 3. And the tolerance band, again, is brown. So the first 3 digits are 100. And then our multiplier, again, is 3, so we want to add 3 more zeros on here. And so the fourth band means 3 zeros, so I'm going to take my 100 times 10 to the third, because orange is 3 positions there. And that's going to give me 100,000 ohms or 100 k ohms for the resistance, and that is the nominal resistance. We would apply our tolerance to get the actual acceptable range. So here we're going to determine the allowable tolerance, and we're going to pick up with that same example that we just had. If we take our tolerance band, it's brown, so it's going to be 1%, and that 1% means the same as multiplying 0.01 times my nominal value. So I have 100,000 ohms here times 0.01. That's going to give me a value of 1,000 or 1K. So if I take my 100,000, subtract my 1,000, I'm going to get 99,000 ohms. And if I add it back in, I'm going to get 101,000 ohms. So my acceptable range here is 99 to 101 k ohms. Okay, what we are looking at is actual pictures of resistors, but we're going to talk in depth more on schematics in another video. But I just wanted to show the symbol that you will see for a resistor in a schematic, which is just a drawing of the electrical circuit represented on paper. This is the actual symbol that you will see in a schematic, and usually its value will just be shown next to the resistor. And so in this case, this is going to be a 37 k ohm resistor somewhere in that circuit on that schematic. So we'll have more lessons on schematics and how to read them in the future. So that is the lesson on resistors. I hope that was helpful. If that was kind of quick, take your time, go back through the video and just go through those different steps, and we'll have some worksheets for you to do to also solidify this. So we'll see you in future videos. We'll see you then.